Welcome. This video covers row manipulations using the dplyr package in R. We know how to document our process now, so we're ready to actually start manipulating our data. We've read it in using our maybe read_CSV, maybe something from the readr package. And now what we want to do is maybe subset the rows, i.e. filter the rows. So we're going to use this language of filtering the rows to mean we want to just get certain observations back. We also might want to just return certain columns. And although we've seen how to return some columns using base R methods, so for instance using square brackets or a $sign, there's a select function in dplyr that's going to give us great functionality for selecting multiple columns at once. And then lastly, maybe we want to create some new variables that are functions of the other variables in our data set. So this age type variable, that whether a dog or a cat is old might depend on the size of the dog. Maybe if it's a bird, birds can live like 70 years. So we want to use the information here to create a new variable that we can use in our analyses. All right, again, we're going to try to stay within this tidyverse ecosystem as much as we can, because this tidyverse gives us this coherent collection of packages that all work well together and have functions that will do most of the common tasks that we want to do, especially around data manipulation and plotting. And remember that the tidyverse works pretty much exclusively on Tibbles, and these Tibbles are just special data frames. They have better printing, and they also don't simplify by default. Another nice thing about staying within the tidyverse is that all of the functions that we use within the tidyverse are going to basically have the exact same syntax for the most part. And that's going to be the function name, the Tibble that you want to be working on, and then whatever actions that function takes in. And that's going to be dependent on the purpose of that function. We'll also see the idea of chaining in coding, and that's going to make our code much more readable. But let's start with the dplyr package. So this is one of the major packages from the tidyverse, and it gets loaded in when you do library tidyverse. And some of the common functions that you're going to use from dplyr include as_tibble. And what this does is it just takes a data frame, a standard data frame, and turns it into a tibble. So for instance, sometimes you'll read in data from a different method or with a different package that does not automatically make it a tibble, and you might want to convert it to one just so it has these nicer properties. And then there's two major functions within dplyr that will do manipulations on your rows. One is the filter function, which is going to allow us to filter or subset the rows. And the other one is arrange, which will allow us to sort the rows. Then for doing some column manipulations, there are three major functions that we'll look at. The select function, which will give us great functionality for choosing certain columns. There's the rename function that will allow us to rename the column names. And then mutate, which will allow us to add a newly created variable to our data frame or tibble. And then lastly, we'll look at group by and if else as additional things that we need to know about in order to create new variables. All right, let's start with some of these row manipulations. Before we do that though, let's make sure we're working with Tibbles. So as_tibble, you can just do what's called wrapping an R object that's already a data frame in this function, and it will coerce it to a tibble. So for instance, there's this package called layman, which if you don't have it already, you'll need to install it. Remember, you only install once, but every time that you open R and you want to gain access to those things, you'll need to run the library command. So we're on library layman after installing that, and we gain access to a number of different data sets about Major League Baseball. And so one of those data sets is the batting data set. And so this gives information on batting statistics all the way back till 1871. But this batting object is a data frame, it's not a tibble. And so whenever we would type this into a console, we would normally just see all of the variables and all of the observations, and it wouldn't be very pretty. So we use this head function to just see the top 4 rows. Well, we can just wrap that object in as_tibble and coerce it into a tibble. And so now I have a new object called myBatting, which is a tibbled version of that data frame. All right, so now we are sure that we're working on a data frame, on a tibble. Now we're ready to subset some rows. The filter function is going to be great for that. But in order to use the filter function, we first need to understand how R does logical statements and logical comparisons. Because what we're really going to want to do here is use logical statements to say, I want to grab the rows that meet these conditions. So I want to grab the observations that meet these conditions, but get rid of the rest of them. So we need to tell R, how to meet these conditions. So we need to understand how R does logical comparisons. So a logical statement, we've sort of mentioned these once or twice, but we haven't really gotten into them. A logical statement is something that returns a true or a false. So again, true and false are special things in R, representing a true and a false value. And so an equal equal will do a comparison of two things. So is this object on the left the same as this object on the right? And you can see here that these two character strings are not the same, right? There's an extra space over here, so this returns false. But if I compare the two exact same character strings, it does say that those things are true. There's the standard mathematical comparisons as well, greater than or equal to. An exclamation point will give you a not equal to in R. So is 4 not equal to 1? True. And then sometimes you run into numerical issues. So this one here is only false due to numerical issues, because truly the square root of 3 squared is 3. But this is going to return false because when it does this mathematical computation, it can't store that variable exactly. And so when you square it back, it doesn't give you 3. And so there's a function in dplyr that actually works a little bit better when you're doing these kinds of numerical comparisons. It's the near function. Remember that this syntax is saying I want to, from the dplyr package, use the function near. It gives us a way to just specify exactly what package this function comes from. And then there's a whole family of is.dot functions. And these is.dot functions are just logical comparisons for is this R object of a certain type or class, that kind of thing. And so we might say something like, is this thing numeric? So is.numeric this R object, a vector of just the character string word. And that's of course false. Is 10 numeric though? Yes, that returns true. And so basically there is an is.dot function for most things that you would think of. Is.character, is.na. Remember that NA, and actually a capital NA, is the missing data indicator in R. So you can indicate which elements of things are missing. And then is.matrix, there's an is.data frame. Those kinds of functions all exist. So how do we use these logical statements to actually filter or subset our rows? Well, the idea is to create what's called an indexing vector, which we kind of talked about before, but this indexing vector is going to be a vector of true false values. So it's going to be a logical comparison vector, a logical vector. And what R is going to do is anywhere there's a true in that vector, it's going to return the corresponding observation. Anywhere there's a false, it won't return it. And so if I create a logical comparison off of a variable in my data set, so for instance here, taking my batting Tibble, I'm grabbing just the games column, and I'm saying if my batting $G is greater than 20, this does a vector of comparisons. This is an entire vector of the game values, compares each one of those elements to 20, and returns a true or false based off of that. So if I feed this in as an indexing vector, I could then return only observations or rows where the games played was greater than 20. Now, if we want to use this in the tidyverse version, we can actually simplify the way that we write things a little bit. So I can use the filter function, which subsets rows. I give it the Tibble that I want to work on, and then I give it the logical comparison over here on the right. So I'm saying filter the my batting data set to only include observations where the games variable is greater than 20. And you can see here that it's kind of nice. I didn't have to do my batting $G or anything like that. All I had to do was put G greater than 20 because it knows that I'm working on the my batting Tibble, so I can just call the variable names by what they are, which is quite nice. Sometimes you want to do a logical comparison that involves more than one variable, and so you need to do compound logicals, and that's very easy to do in R. You can either use the ampersand for and or the vertical bar for or. And of course, this kind of thing, the and operator is only going to return true if A and B are both true. If either one of those two is false, or if they're both false, the and operator returns false. If either one of those things is true, though, the or operator will return true. It only returns false whenever both statements that you give it are false. So how you use this thing is you put two statements on, one on the left and one on the right. And here we're saying I only want to look at games where the games variable is greater than 20 and the year ID is equal to 2015. And so this is going to do a compound and. This is a compound logical. This condition and this condition must be true to return a true, otherwise it returns false. But again, we don't need to use this sort of $ syntax with the data set specified twice. When we use the filter function, we can just say filter my batting, so it knows I'm working on that Tibble, and then I give it the compound logical over here on the left. You don't actually need these parentheses. R will read things appropriately, but it is nice to just put those in just to be careful to make sure it's saying that this is one logical comparison and this is the other logical comparison that I'm doing. But now you can see it's only returned observations where the year is 2015 and the games is greater than 20. There's another really useful operator to do sort of compound logicals in a shorthand manner, and that's the percent in percent operator. And so for this, what it does is it looks at the variable you give it on the left, so for instance team ID here, and it says, I'm going to return any observations where this thing is in, i.e. has one of these values over here in this vector. So we give it a vector of values to compare to. And so here, any observation that had Atlanta for the team or Pittsburgh or Washington is returned. All right, so that's how we can filter or subset our rows. We can also arrange or reorder the rows using the arrange function. This is the other major operation that you'll do on rows. And it's got the exact same kind of syntax. Again, kind of nice thing about being in the tidyverse. We're going to call the arrange function. The first argument is the Tibble I want to work on. And then I tell it which variable I want to reorder based off of. And so it's going to do alphabetically first A to Z for starters. And so I think this is Altoona comes first. You can, of course, specify multiple multiple variables as well. So here I'm going to say arrange the my batting Tibble based off of the team ID. And then after team ID is sorted, within there, sort the games variable from smallest to largest. So we've sorted by alphabetically by this variable, and then smallest to largest by this variable. Of course, sometimes you want to arrange descending on a variable, so opposite. And so you can use DESC around whatever column that you want, and it's going to do that descending. So now this is games largest to smallest. And so those are the two major operations that you're going to do on rows using dplyr. Let's jump into R and play around with some data ourselves. All right, here we are in our studio. Let's go ahead and play around with dplyr. I've created a new RMD document that we will go through and document all of the different examples we do using dplyr. You might notice here I put little backticks around dplyr up here in my title. And if you knit this document just with this little bit of information, those backticks just create what's called code font. So if you have certain things that you want to just stand out and say like, hey, this is code, I don't want to evaluate it or anything, but I want it to show up differently. Those two backticks around it will make it code font. And so we have our setup code chunk. We need some data to read in. Let's go ahead and put a header here, read in data. There's a wine data set that we can read in. So we'll go ahead and grab that. That's available here. Wine quality full will be what we grab. So I'll just right click on that. I'll do copy link so I get the path to it. And now I'll insert a code chunk using my hotkeys, and we're going to need the tidyverse, or at least the readr package to read this in. So I'll just go up here in my code chunk, set my setup code chunk, and put in tidyverse. And now when I'm down here, let me go ahead and make sure I run all above code chunks so that tidyverse has been read in. And now I will go ahead and read this in using read CSV. I'll create a new object called wine data. That's read underscore CSV of this path to the URL. And we'll type in the object as well, and we'll see if that read in correctly. And we can either hit this button here, or we can just run this code line by line as well. So I'll just send that to the console. Looks like it read in one variable as a character and 12 as numeric, which sounds about right. Let's take a look at that wine data set by running that object, and we can see it does look like it read in okay. Gives us a nice way to sort of cycle through the variables and the observations as well down here in this little code chunk output. Great, so we got some data. Let's go ahead and do some row manipulations. So looking at that data set, right, there were a number of different variables that we could think about with the wine data. One of them was actually the type of wine. And so let's just look at red wines. I can go down here, put in a new code chunk. I can say, let's filter, because we've already read in dplyr when we read in the tidyverse. So I'll say filter, take the wine data, And then there was a type variable. I want to say type equal, and I'm actually not sure whether it's uppercase or lowercase red. So let's go up here. Let's open this, scroll down and look at type. So it looks like the red ones are capital red. And we do have to be careful when we're in quoted strings to match case. R is case sensitive generally as well. But I'll say type equal equal. Remember, 2 equals is the comparison operator. Type equal equal red. I'll run that code. And now I only have 1,599 observations, where up here I had 6,497. So we did subset the rows, probably appropriately, which is nice. Okay, well, let's also do another one. So here let's look at red wines where one of these variables has another value. So maybe fixed its acidity is greater than 8. Oops, 8. Jump down here, put another code chunk. I'll copy the same code that we had up here. Come down, plop it in. And now if I want to do a compound logical, one thing that's nice to do, wrap this in parentheses. And is our compound logical for ampersand. And then I want to do fixed acidity. And actually, this is a weird variable name. All right, so this has a space in it. That's a non-standard name. How do I access something like a non-standard name? Well, if I start typing in wine data, do a $, it does come up here as fixed acidity. I hit tab. Notice that it has those backticks around it. So if I want to use this variable as is, I need to include those backticks. So we'll do that. So we'll say fixed acidity greater than 8. Let's run that. So notice now we're only getting 741 observations. So we're able to do some basic filtering of our rows. Well, we might want to take the result of this and maybe then arrange that based off of the fixed acidity, perhaps. So we'll do that. I'll copy this code so we can pull it down to the next code chunk. All right, so we're going to now sort the data by fixed acidity. Great, no problem. We'll paste down our code chunk. And although we're going to learn how to do chaining later, which is going to make this much more readable, what we might do at this point would say put a range around the result of that. Right? We've now filtered our data. With the result of that, I want to now arrange it. So the result of that filter command will be a filtered data set, so a smaller Tibble. Now I want to arrange this based off of the fixed acidity variable. I'll run that. And now it's sorted by that from smallest to largest. Let's go ahead and make it descending on that. Largest first. Sorry, I don't know what key is end on this keyboard. Here we go. And now the most fixed acidity is 15.9. So these are some basic row manipulations that we might do using the filter function and the arrange function with dplyr. All right, to recap, we have this dplyr package that's going to be really useful for doing most of our common data manipulations. As_Tibble to coerce a regular data frame to a Tibble, filter and arrange to subset, and reorder the rows respectively. There's a great cheat sheet for dplyr that's available in this link as well.